Hey guys, Mr. Bowman here. This is a video just for fun, and we are trying to find the area of any given regular polygon. So before we get into the video, let's quickly explain what is a regular polygon. And a regular polygon is a shape where all of the sides are equal to each other. So that there would be an equilateral triangle. It could also be a square. All of those sides would be equal to each other. It could be a regular hexagon, and that's a bad example, but all of those sides would be equal, and it actually could be any other shape, any decagon, heptagon, pentagon, nonagon, anything with all the sides that are equal. So I'm going to show you how I approach this question. And when I was doing this question on my refill paper, I actually came up with a formula that would have worked with any of the shapes. So let's get into that. So the example that I had a regular hexagon. So that was a regular hexagon. And the only bit of information I knew was that the sides, they were all equal, and the sides all had a length of 6 centimeters. And I was trying to find out, well, what's the area of that shape? And it took me a while to get it, but then I had a bit of a brain light bulb moment, and we're going to go through that light bulb moment with you today. So firstly, let's get rid of that 6 centimeters because we don't need that yet, and I'm going to change to the blue pen color. So we're just going to show you how did I come up with a general formula that would work for all shapes, and then we'll then apply it to this hexagon. So the first thing I noted was I put a dot in the middle, and if we go back to the right-hand side, we could put a dot on the middle of all of those shapes. And what happened was, if you connected that dot, all of those shapes were constructed from triangles. So the main focus of the formula was about that triangle formula. So let's have a look at our one. So that went down there and that went down there. So what we were trying to do is we were trying to find the area of one triangle, because that triangle would be the same here, 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 and here. So there would be 6 of those triangles all in the same place. So the formula started with, so area of polygon, or I should be more specific, of regular polygon. Regular polygon. Well, that was equal to the area of the triangle times the number of triangles. So that was where I started. And the next thing I figured out, well, how many triangles were there? So that relates to the variable on the right. And the number of triangles actually related to the number of sides in the shape. So for example, here was one triangle, and there'd be another triangle here, another triangle here, another triangle here, another triangle here, and a final triangle there. So that meant the number of triangles was actually going to be equal to the number of sides. So triangles was equal to the number of sides. So that meant we could actually change our formula. So the number of triangles, well, that's gone away. And that there was equal to the number of sides. And I'm just going to call that n from here onwards. And I think hopefully we all know, but we know how to calculate the area of a triangle. So that would be 1/2 of base times height times n. The next bit of information we need to work on is the area of the triangle. So the area of the triangle is base times height. So I'll have to use a different pen for this. Let's use yellow. So if we're going down the middle here, that there would be height. And across the side there, that would be the length of that triangle. So what I am going to do here is I know the base of the triangle is going to be the length of one of the sides. So I'm going to sub out the base for the length of that. So let's change back to blue. So 1/2 times length times height times the number of sides will be equal to the area of any regular polygon. And the last bit we've got to work on is, well, how do we figure out the height of one of these triangles? And this is where it took me a while to get into it, but eventually I found quite an easy solution. So one thing we do know is angles around a point, they are going to equal or sum to 360 degrees. And we know this hexagon comprises of 6 triangles, which means that 360 needed to be divided up into 6 lots. So 360 divided by 6 gave us 60 degrees. So that means the base of this one here, that there was 60 degrees. And that actually suggests it's going to be an isosceles triangle, which makes our life a little bit easier regarding, sorry, not an isosceles triangle, an equilateral triangle. That will make our life a bit easier, but we still need to figure out the height. And because this is an equilateral triangle or an isosceles triangle, these two angles, well, sides are going to be the same, and that means that 60 degrees is going to get chopped up. So if we draw another triangle down the bottom here, so we're going to chop the equilateral triangle in half, which makes this portion here 30 degrees. And what that also makes is this portion here is going to be 1/2 of L. And with that information, you should be able to find out the height of this triangle using trigonometry. So let's get into that. So there's our right angle. Over here, that's going to be the opposite. Here's the hypotenuse. We're not interested in that, which means this one here would be the adjacent. So that means we're going to be using a tan formula. So tan delta is equal to O over A. Tan 30, and it's really important, where did that 30 come from? So we need to actually rub that out. In terms of maths, what was that 30? So that 30 was actually equal to 1/2 of 360 divided by n. So just clarify where that was. So 360 divided by n, so that was 360 divided by the number of sides of that triangle. And because we chopped this triangle in half again, that's where we got that times 1/2 from. And if you did simplify that, there would actually be 360 divided by 2n, which would be 180 divided by n. So tan here is actually going to be 180 divided by the number of sides of the shape. That's going to be divided by the opposite, which is 1/2 of L. And that there will be divided by the height of the triangle. And what we can do mathematically, we can just switch the height and the tan function here. So that height will be equal to 1/2 of L divided by tan 180 divided by n. And that can be simplified for one more. We can drop the 2 and the half down to the bottom. So L will be equal to 2 times tan 180 divided by n. And that gives us the last part of our formula. So let's change pen colors and let's put that in. So that means the area of our polygon is going to be 1/2 times L divided by 2 tan 180 divided by n times n. And here, that was all of the components of our formula. So for any given regular polygon, we'll know 2 things. We could know the side or the length of each side, and we can easily figure out how many sides there are on a given shape. So let's finalize and simplify this. So that L is actually going to be L over 1, and that N is N over 1. So that's going to be 1 times L times L times N, which is going to be L squared times N. And that's going to be divided by 2 times 2, which is 4. 4 tan 180 divided by n. And what we've got there is we've got a mathematical relationship or a mathematical rule that will tell us the area of any given regular polygon. The only things you need to know L, which is the length of the sides, and you need to know N being the number of sides. And we can very easily count that last one. So hopefully you found the rule or this part interesting. What we're going to do now is we're going to apply this rule. We're going to see, does it actually work? And we're then eventually going to answer our question, what is the regular, or what is the area of the hexagon that we are looking at? So what I'm going to do here is I'm going to pause the video. I'm just going to clear some of our working. I'll put a nice tidy formula up the top, and we're going to get into some examples where we apply this formula that we just developed. Okay, guys, we're back. I've cleared up our screen, and we've got our nice new formula up in the middle in blue. So the area of the polygon was L squared times N. All of that was divided by 4 times tan 180 divided by N. And just to recap, N relates to the number of sides of the regular polygon, and L relates to the length of those sides. So we are eventually going to get to our hexagon question, but I just want to test, does this formula work? And I thought the easiest example to apply that was our square over here. So what we're going to do is we're going to pretend that this square has a side of 8 centimeters. And I'm hoping I'm recapping what we know, but the area of that square is just going to be base times height. And that there is going to be 8 times 8. And that there will get us to 64 centimeters squared. So that was really easy. But let's see, does our formula work for a square? Because a square is a regular polygon as well, so it should work. So let's change pen colors. Let's get into yellow, and let's see if the area will work. So the area is going to be equal to, so L, so the length of each side, we already know that's 8, and the number of sides, well, we know that there are 4 sides to this square. So that's going to be 8 squared times 4. That's going to be divided by 4 times tan 180 divided by 4. And 8 squared, that's going to get us to 64. 64 times 4, and that's going to be tan, and then 180 divided by 4 is 45 degrees. And if you put tan 45 into the calculator, that's just going to be 1. So that's going to be 64 times 4 divided by 4 times 1. And from here, well, times 1, that's not going to change anything, so we'll cross that out. The divide by 4 and the times 4 up here, they're going to cancel each other out as well. And that leaves us with 64 centimeters squared. And if you have a look, those two there match each other. So the simple base times height area that works for a square, that is the same answer as our new formula that we've developed. And the reason the new formula that we've developed, so we got an area for a triangle, we have an area for a square, but we don't have rules for our other regular polygons. We don't have rules for pentagons, hexagons, heptagons, octagons, nonagons, decagons. We don't have rules for those, and we can now apply our new rule to find out or answer our query about the regular hexagon. So I'm quickly going to clear our working, and hopefully you'll remember what I said the length of one of our sides of the hexagon was to start off with. And I did say that was going to be a 6 centimeter length. So I've got this work away. Let's get to the yellow pen again. And we said that was going to be 6 centimeters. So the number of, or the length of each side for our hexagon, that's going to be 6. And the number of sides, well, that's also going to be 6. So don't forget, by chance, they're both 6. It won't always be the case. So let's get into the maths. So the area of this regular hexagon is going to be the length squared. So 6 squared times 6. That is going to be divided by 4 tan 180 divided by the 6 sides as well. That's going to be 36 times 6 divided by 4 tan 30 degrees. And from here, we will need to use our calculator because I definitely can't do that math in my head. 36 times 6, that's going to be 216. 4 times 10, 30. That is going to be 2.3094, and I rounded that to 4 dp for simplicity purposes. And we go there, so 216 divided by that answer, that is going to get us to an area of 93.53 centimeters squared, and I rounded that to 2 dp accordingly. And voila, just like that, we've answered our question. So hopefully you found this video useful. What we did is we constructed a formula to calculate the area of any regular polygon. And what, believe it or not, this formula will apply to any regular polygon. Doesn't matter how many sides it has, it will work. All right. Thanks for watching, and hopefully you enjoyed this video on maths, and it was just for fun.